Hello everyone, my name is Fahad Khalid. I am lab engineer here at SIX. Uh, Today I'm going to explain you about the radiated emissions test in our pre-compliance EMC lab. Radiated emissions are basically emissions that are emitted by any device wirelessly in its environment, and we're gonna check whether it is below the limit line or not. In today's lab, we're gonna test Redmi um, phone as a demo device, which will be used as a equipment and a test in our lab. The equipment that we will need to perform this test are as following. For the radiated emissions test, we're gonna need this EMI receiver, which is basically a advanced form of spectrum analyzer. It has built-in EMCI standards. We're gonna, as I have told you before, we're gonna test our Redmi Note phone for our demo purposes, which is what a home appliance. So we're gonna do the CISPR 32 class B test. We're gonna use the class B limit line for our this demo test. This is basically a spectrum analyzer advanced form EMI receiver, which is connected to this wire, and this wire inside the chamber is connected to an antenna, which is basically a log periodic dipole array antenna, LPDA. And as you can see that it is connected to that connector. This is basically our EMCI pre-compliance semi-anechoic chamber, and this is our device under test, which is basically a Redmi Note phone. The device under test is placed at almost 3 meters from the antenna reference point, because we are going to measure it at 3 meters. Now to perform test, we're gonna close this door and we will come back to this EMI receiver screen. The currently antenna LPDA is currently in horizontal polarization position, so we're gonna observe the horizontal polarization waves coming from it through this antenna. Now you are seeing on your screen is basically a EMI receiver display GUI. Basically, in the last video I have explained you about the basic interface of this EMI receiver in conducted emission. In today's we're gonna have to change the limits of this uh, EMI receiver, which is basically a spectrum analyzer. Basically, the CISPR ranges started from for radiated emission started from 30 megahertz till 18 gigahertz. We're gonna perform these experiments in steps. First, we're gonna check its emission from 30 megahertz to 1 gigahertz. As I have told you before, the LPDA attached inside that chamber, semi-anechoic chamber, is of ranges from 30 to 1 gigahertz, and for 1 gigahertz to 18 gigahertz we're gonna need another antenna, which is horn antenna, which will be placed later after this test. As I told you before, the antenna placed under is placed in horizontal polarization, so the any emissions coming from that device under test, which is a mobile phone, in horizontal polarization will be captured by this antenna and will be displayed here. So first I'm gonna select this 30 to 1 gigahertz, 1 gigahertz, and I will go to this. I will go to the detector. Trace one detector is already quasi peak, which I have previously explained. Now I will go to the recall setup. I will call the limit for EN CISPR 32. Now we're gonna call the radiated for class B, and previously we have perform the conducted emission type. For that we have called this conducted class P quasi peak. Now in this lab we're gonna need a quasi peak class B quasi peak detector for 3 meter. So we also have the limit line for 10 meter. As our chamber size is not that big, so we're gonna test it for the 3 meter using that quasi peak detector. And again we have some formulas to transform 3 meter readings to the 10 meter for our references. If someone needs a test required for 10 meter or 10 meter, it is adjusted according to that. So it depends on your end user that at which position it requires this test. So we here wanna perform this class B radiated emission test for 3 meter using quasi peak detector. I will press this, I will press the recall button. As you can see that a shallow line is appearing here as a limit line. So coming back to the main thing, that is correction factor. Correction factor plays a very important role in our testing. The correction factor 1 is of basically antenna factor, and correction factor 2 is of basically cable that is connected through EMI receiver to that antenna. That cable losses are also captured here, so that we can get the exact measurements here on our screen. As I have told you before, that this is basically a pre-compliance EMC lab, so it has some leakages around GSM band, which will be considered as a noise floor or a reference. So any other emissions coming from the device will be considered as its emissions from the device. Now we're gonna start this measurement. We have placed that antenna in a horizontal polarization. The device under test is placed, the mobile front side is placed, and the one more important thing, the device under test will be tested in all 6 possible directions, that front, back, left, right, or top, bottom. So that we're gonna have to make sure that none of the emissions are coming, that any emissions coming from any side will be captured here, to see whether it is safer to be used at homes or not. As you can know that these mobile phones are designed for daily use or home. So I'm gonna just press the scan button and see the response. I think I forgot to add this correction factor. As you can see that if I turn it off, the limit line is way below the so let's wait for it aligning. The email receiver itself align its filter. As you can see that when correction factor is off, the values that are coming is around 20 dB microvolt. Whenever I put this on, as you can see, it shifts to around 27, which is basically a correction factor to cater all the losses. Now as you can see that trace fail 1 is appearing on the screen. Basically this is basically when I press this peak search button, this is basically a GSM band emissions, which is acceptable, because as we know that mobile phone does have GSM signal in coming and outgoing from mobile phone simultaneously. So we're gonna wait for few minutes to see whether this is stable or not. And again, aligning, automatic auto aligning is happening. Basically the filter in this CMR receiver align itself to give us the as accurate as those values. I will explain you again that the start frequency for the radiated emissions is 30 megahertz, and we have set the stop frequency at 1 gigahertz because the antenna that are used inside is of LPDA, and its ranges from 30 to 1 gigahertz. For 1 gigahertz to 18 gigahertz, we're gonna need another antenna, which is horn antenna, which will be placed later after this 30 to 1 gigahertz megahertz. As you can see that the values coming, emissions coming from it are very below the limit line, so it is passing it, only it's failing at the GSM band, which is acceptable because it is designed to communicate. Now I'm going to press this stop sequence, and I'm going to change the polarization of the LPDA, or in fact I will change the uh, side of that DUT, basically device under test, which is basically a phone. We are now seeing the front side of it. After that we're going to see the remaining 5 side of it. So I'm going to stop here, and I will press this search button. As you can see that it is failing on GSM band, which is acceptable. So I will just delete this signal, and I will move to the DUT position. Now we're gonna flip the side of it, and we're gonna flip from front side to back side, and we're gonna check the emissions coming from it back side, making sure that it is placed at 3 meters from the antenna reference point. So we are back again on the EMI receiver screen. We're gonna move to the measurement, and we're gonna press this scan button. The setting will be same frequency range. Same VBW, RBW as defined by standard. As you can see that it is also same trend is following on the back side. Basically this changing of side is helpful when we are testing a big module, that's for the power supply or anything like that. Basically with the help of this changing the side testing, we're gonna check that whether the emissions coming from it or from which side. So we're gonna have to focus on that side, that there are something in it that are emitting the emissions. As this is basically a compliance mobile phone, so that's why it is passing this test easily. So I'm gonna just put this stop sequence button, and now I'm going to change the side of the phone for another test. Now we are going to change another side of this DUT, basically, which is a cell phone. We're gonna check it from its left side. Now we are back again on the EMI receiver window. I'm just gonna press this scan button. As you can see, that's almost same trend is following on the left side. Same signal, GSM band signals are appearing from the device. Other than that, there is almost a straight line. I will wait for few minutes to check whether another emission in that band can come from this DUT, which is basically a mobile phone. Now I'm pressing the stop sequence. I will check it for another side. Then I will skip the two side as you see that it is passing the test, and I will move to this vertical polarization of antenna and will check it again on all sides. Now I have changed the polarization of antenna. Now antenna is in vertical polarization. Now I will check the side I have tested in horizontal polarization. As antenna is on the left side, I will check this left side first, then I will move to the all other sides. Now we are back on the EMI receiver screen. There is some error appearing. For that I have to align the filter of it. I will just put this scan button. The start and stop frequency will be same. As you can see that now in vertical polarization, not even a GSM signal is appearing. So the GSM signal appearing from the phone are in horizontal polarization when it is laid down on the table. I will wait for few minutes to check whether some signal or emission coming from it. As you can see, there is a little GSM signal appearing on it, which is just above the limit line. That's where trace 1 fail is appearing on the screen. Now I will press this stop sequence button. I'm satisfied with the results, and I will move to the another side of the mobile phone, which is device under test. Now we're gonna move this left side to the front side of the or top side of the mobile phone to check emissions coming from it in vertical polarization. Now we are back on the screen. I will press this scan button. Check the emission. Boom. From the front side in vertical polarization, it is also receiving the GSM signal, which is fine because the phone is on and its SIMs are working. I will wait for a few minutes like previously to see any other more emissions in this frequency band appears from the mobile phone or not. Auto aligning is turned on. I'm gonna wait a few more minutes. As you can see that the response is stable. Now I will press this stop sequence and I will check the one more side in this vertical polarization, that will be backside, and after that I will skip the remaining side, as I am satisfied with this BUT performance. And if and to make this video short, I will skip it, and I will after that I will change the antenna under inside the chamber. I will place a horn antenna which ranges from 1 to 18 gigahertz for higher frequency values. Now let's move inside the chamber to change the side of the DUT, which is mobile phone. Now we're going to change the side of the mobile phone and will check the emissions coming from its back in the vertical polarization. Antenna placed inside the chamber is in vertical polarization. Now we will close this semi-anechoic chamber room to check its response on EMI receiver screen. Now we are back on the EMI receiver screen. I will just put the scan button because start stop frequencies PBW RBW are already set. Detector is also already selected, which is positive peak, and max voltage option is selected for trace 1. I will just press this scan button. As you can see that it is only emitting the GSM band frequency signals. Other than that, it is passing this radiated emission test in both vertical and horizontal polarization for a band starting from 30 MHz to 1 GHz. One more I will explain here that mostly the device comes here for pre-compliance test fails this test. You can say that 90% of devices fail this 30 MHz to 1 GHz test because the component that they use inside produces some type of oscillations or emissions that are radiated wirelessly, and that wirelessly emitted emissions are captured by our antenna placed inside it, which will consider as a fail if it passes the limit line in this range. I will wait for 4 minutes, then I will press this stop sequence button. I will just put this stop sequence button, and I will just move into the my standard, and I will select this 1 to 18 gigahertz. Above 1 gigahertz basically is used till 18 or 40 gigahertz are used by military standard, but in CISPR class B category here, just like we have tested a device, we're gonna just test it this at 1 gigahertz to see whether it is passing that test or not. From our calculation, from our test for our demo movements which we have performed on this DUT, which was mobile phone, we can see that in both vertical and horizontal polarization that it is passing this test. So it means that it is safer to be used in at homes or in our daily lives. Let's suppose if we have any military device, then we're gonna have to check its response till 18 or more than 18 as per desired need, and for that it also have different limits. Let's see if I recall this limit line for mil 461. As you can see that it is very different for each and every application. So that's it for today's radiation emission test. We have checked the radiated emission test of Redmi Note mobile phone. We have checked its frequency, its response emissions from 30 megahertz to 1 gigahertz as per standard. BBW and RBW defined by standard limit line. We have called it CISPR 32 class B for home appliances, and as we see that it is passing the test. Only the emission coming from it was around GSM band, which is acceptable because it operates on it. So that's it for the today. I will be back with another video about radiated immunity and conducted immunity later. Thank you.